Generative AI refers to algorithms that can generate new content, such as text, images, or even code, based on the data they have been trained on. These models, like GPT-3, have revolutionized various fields by enabling machines to perform tasks that require creativity and understanding. In the context of coding, generative AI can assist developers by automating repetitive tasks, suggesting code snippets, and even generating entire functions or modules based on high-level descriptions. In modern software development, efficiency and speed are crucial. Generative AI helps developers by reducing the time spent on boilerplate code and allowing them to focus on more complex and creative aspects of their projects. This not only accelerates the development process, but also reduces the likelihood of human error. By leveraging AI, developers can ensure that their code adheres to best practices and is optimized for performance. Submitting requests to generate code involves interacting with a generative AI model through an API or a user interface. The request typically includes a prompt or a set of instructions that describe the desired functionality. The AI model processes this input and generates code that meets the specified requirements. Understanding how to craft effective prompts is essential for obtaining useful and accurate code from the AI. The quality of the generated code heavily depends on the clarity and specificity of the prompt. A well-crafted prompt should include detailed descriptions of the desired functionality, any constraints or requirements, and examples if possible. For instance, instead of asking for a function to sort a list, a more effective prompt would be a Python function that sorts a list of integers in ascending order using the quicksort algorithm. This level of detail helps the AI generate more accurate and relevant code. Many generative AI models offer APIs that developers can use to submit code generation requests. These APIs typically require authentication and provide endpoints where developers can send their prompts. The response from the API includes the generated code, which can then be integrated into the developer's project. Understanding how to use these APIs, including handling authentication, formatting requests, and processing responses, is crucial for effectively leveraging generative AI in coding. Once the AI generates the code, the next step is to integrate it into your project. This involves reviewing the code to ensure it meets your requirements and adheres to best practices. Developers should also test the generated code to verify its functionality and performance. Integration may also involve refactoring the code to fit the existing codebase and making any necessary adjustments to ensure compatibility. While generative AI can produce high-quality code, it is essential to review and test the generated code thoroughly. This includes checking for syntax errors, logical errors, and performance issues. Developers should also ensure that the code follows best practices and coding standards. Automated testing tools and code review processes can help in maintaining the quality and reliability of the generated code. Errors and bugs are inevitable in software development, and generated code is no exception. Developers should be prepared to debug and fix any issues that arise in the generated code. This involves understanding the logic and structure of the code, identifying the root cause of the problem, and implementing appropriate fixes. Familiarity with debugging tools and techniques is essential for efficiently resolving issues in generated code. The use of generative AI in coding raises several ethical considerations. Developers should be aware of the potential for bias in AI-generated code, as the models are trained on existing data that may contain biases. Additionally, there are concerns about the impact of AI on employment and the potential for misuse of AI-generated code. It is important to use generative AI responsibly and consider the ethical implications of its use in software development. The future of generative AI in coding is promising, with advancements in AI models and techniques continually improving the quality and capabilities of generated code. As these technologies evolve, we can expect even more sophisticated and accurate code generation, further transforming the software development landscape. Developers should stay informed about the latest developments in generative AI and be prepared to adapt to new tools and methodologies. To illustrate the practical applications of generative AI in coding, consider a case study where a development team used AI to automate the generation of boilerplate code for a large-scale web application. By leveraging AI, the team was able to reduce development time by 30%, allowing them to focus on more complex features and improving overall project efficiency. This case study highlights the tangible benefits of integrating generative AI into the development workflow. To maximize the benefits of generative AI in coding, developers should follow best practices such as crafting clear and detailed prompts, thoroughly reviewing and testing generated code, and staying informed about the latest advancements in AI technology. Additionally, developers should consider the ethical implications of using AI and strive to use these tools responsibly. By following these best practices, developers can effectively leverage generative AI to enhance their coding productivity and quality. Generative AI has the potential to revolutionize software development by automating code generation and enhancing developer productivity. By understanding how to submit effective code generation requests, integrate and test generated code, and consider the ethical implications, developers can harness the power of AI to improve their projects. The next steps involve exploring available AI tools, experimenting with code generation, and staying updated on the latest advancements in generative AI technology.